ladies and gentlemen, welcome, welcome, welcome. I appreciate you being here with me tonight. It is an absolute honor. It is a privilege to be here with you, to serve you and help you learn and shape your lives for the future. That's why I do what I do, as I love it and I love helping young ones like yourselves learn and grow, not only academically. Academics is one thing, but growing as a person of character, growing as a person of intelligence, growing in a way that takes you wherever you want to go, to do whatever you want to do. And this is just one small part tonight of all the opportunities that I have to be with you. So we're going to continue in lesson 5.5, our big ideas, page 194. We're going to cover two topics tonight. Both of them are kind of a review, so it shouldn't take too long. And then this is the last video of Unit 5. So let's get busy. But we're going to review and define slope, and we're going to interpret the slope from a graph. All right? Our essential question, how can you use the slope of a line to describe the line? Well, that's interpreting right there. So you should have taken a few quick key notes from the top of page 194. They were review notes. And let's get busy talking about some of the things that we have learned. Because unfortunately, slope has many definitions, and we need to understand them all. So we're talking about the word slope. We know it's represented by the letter M. And when we're talking direct variation, they talk about it as the letter K in the equation y equals kx, because there's no intercept. The intercept is the origin in direct variation, but this equation is still in slope-intercept form, y equals kx. And so sometimes we talk that slope is represented by k. I hate that. I always want to use the m. So let's continue on. We know that slope is the change in y over the change in x. It's also the vertical change to the horizontal change. Using the formula, it's y2 minus y1 over x2 minus x1. We call that the rise over the run. We also call it the constant rate. I'll tell you what, I can spell. C-O-N-S-T-A-N, constant rate of change. And when we're talking direct variation, because direct variation deals with proportional relationships, we call it the constant of proportionality. A lot of names for slope. All right, a lot of ways to interpret slope. So let's remind ourselves, when we're given a graph, we can find slope. And of course, finding slope being the rise over the run. Let's review that real fast. Rise over run. And remember that rise is either positive because it goes up or negative because it goes down. We're either counting up or we're counting down. From the left to the right, remember, just like we read, left to right, we either have to go up or we have to go down to get to the next point. And then we run to the right in a positive direction. Can we reverse? You bet we can, but typically run is to the right. All right, so when we count, we can just start at some point on the left, right here at 0, 0. We recognize that the next point in going to the right is up, so we go up 1, 2, 3, 4, 5, and the run being 1. So we say our slope is 5 over 1. Remember, when we have a run of 1, we don't have to write it, and so we just call it 5. If we did it, well, we won't do it this way. We'll talk about that later. Coming over to the next one, we have, starting on the left, right here at point -2, 1, we're going to our next point, which we have to go down to get to because it's to the right, 0, -3. So we count down 1, 2, 3, 4, and then we go over 1, 2, and so our slope is -4 over 2, which when we simplify again is -2 over 1, which is -2. Outstanding. So let's just get busy doing what we know how to do. Find the slope of the line from a graph. And we just talked about it. So once again, we just count. If they're giving us the graph, we might as well just count. And so we're going to count down 1, 2, 3, 4, 5. We had to go down 5. And when do we have to go over 2? So our slope for this one, -5 halves. I can't simplify that. I could say the slope was 2.5 over 1. Remember, -2.5 over 1. Slope is a ratio. It is a ratio and a comparison of numbers. Even though we can write ratios and make slope look like a fraction, we can still have decimals and fractions in our, decimals and fractions in our slope, because slope is a ratio. It's not a fraction. It just looks like one, acts like one, and has some properties that fractions have. So either one of these is absolutely acceptable. You could take the slope to the unit rate. Let's find and interpret slope of a line. We can practice interpreting. So we're looking at this graph of the water tank, and we see that the rise is the height in inches, the run is the volume in gallons, and we can see that as this tank fills up and has more gallons, the level of the tank rises. So what we need to do is look for some points. So I have a point right here at 0, 0. That means we know that this is a proportional relationship, because if it doesn't have any gallons in it, it can't have any inches in it. And then we have to find another point. And I'm telling you, I'm thinking there's probably 2 other points that work, right here and right here. So either one of those we can use. All we need is 2 points. We really only need 1 when it's a proportional relationship. Obviously 0, 0 doesn't work. But we could have 40 over 2. Oh, excuse me. Hello. Wrote it wrong. I wrote the x over the y. Remember, it's change in y over the change in x. And if I go across and go down, that's 2 over 40. So 2 inches for every 40 gallons. Okay, I could write and simplify that to 1 over 20. And if I go to that next point where there's 80 and 4, again, I can put 4 over 80, which does simplify to 2 over 40, which does simplify to 1 over 20. So we recognize that the slope is 1/20th. Meaning, when we interpret this slope, we talk about the rise first. That means that it rises 1 inch for every 20 gallons. Okay? So that is interpreting the slope. Could I say it different ways? I certainly could. So we found the slope, 1 over 20, and we interpreted the slope right there. Find the slope from 2 points. Remember the slope formula. Slope m is equal to the change in y over the change in x. So this is the change in y, and this is the change in x. How do we find the change? We subtract. That's right. So we take y2 minus y1 over x2 minus x1. And remember, it matters not which one of these points is x1, y1, and which one is x2, y2. I'll do it both ways real fast. So we're going to do x1, y1, x2, y2. And when we plug that into the formula, y2, -1, minus y1 is 5, over x2, 1, minus x1, -2. Now when we do that math, we get -6 over 3, which is -2 as our slope. Okay? I can do it the other way. I can change and say that this is x2, y2, x1, y1. And when I subtract that way, y2 now becomes 5 minus y1, which is -1, over x2, which is -2, minus x1, which now becomes 1. And so now what we get is 6 over -3, which once again simplifies to -2. So matters not which one of these points is point 1 and which one is point 2. If you follow the slope formula, you will get the slope. And lastly, find the slope from a table. We're going to interpret this slope as well. We have this table, and probably using our slope formula, we are going to take any 2 points. So I'm just, for the heck of it, going to take these last 2, and I'm going to call this point 1 and this point 2. So we know that typically x is on top and y is on bottom when we have a table, typically. And it only makes sense that the number of sold per minute. And so when we look at this, we would have then 10, because that's 2, minus 7.5 over 4 minus 3, which gives me 2.5 over 1. Oh, well, there it is right there. 2.5 over 1. So my slope is 2.5, which, when we interpret that, we always talk about the y first. That means 2.5 wraps sold, every minute. Now, if you want to get to real life application of that, I'm thinking they probably don't sell half wraps. Maybe there are restaurants that sell half a size of pizza or half size bowl of spaghetti, but I'm thinking they probably don't sell half wraps. So if you take that up to the next one, 5 over 2, to say, hey, I'm selling 5 wraps every 2 minutes, that might make a little more sense. M-I-N-U-T-E-S. I'll tell you, you got to work on my spelling as a math teacher. So there's a couple ways of looking at it. So ladies and gentlemen, we're done. We're done with this one. I know I spent a little bit of time, but it's good review. Here it is. Make sure you pause it so you can write these down and find the slope of the line from the graph and find the slope from the 2 points listed. Then take a quick break and come back for video number 2. Thank you.